Hi, on behalf of our team today, I'm going to tell you about our project to improve mobility options for communities. We are especially thankful for NSF for giving us the opportunity to work on this problem of immense importance. Our community partner in the project is Chattanooga Area Regional Transportation Authority, CARTA. It is responsible for operating a multimodal transit system in Chattanooga, Tennessee. The current public transportation options are concentrated in the downtown and leaves a large number of people in the outskirts of the city without good access to public transportation. The challenge we face is to solve the issue while ensuring that the city is able to operate a well-designed public transportation that is economical, efficient, and equitable. To understand the community needs, we started with focus groups that were virtual during the early part of the pandemic. This was followed by surveys. We highlight two responses in the slides. The first describes how the general public uses public transportation. There is a large population who does not get to use the public transportation yet. From the people who use the systems, they use it primarily for accessing jobs and running errands. Further, a large number of people who use the public transportation belong to the low-income group. As the next set of questions, we try to understand how people that use transit connect to other modes. Of the people that make the connections, bikes were the chosen option for the first and last mile. Another question we asked helped us identify that people preferred better connectivity and coverage with more stops and were ready to sacrifice ride time performance. Lastly, we found out that a large number of people were in favor of dial-a-ride or microtransit option that we are building. Let me now describe our core algorithms that have been developed in the first half of the project. Microtransit or dial-a-ride operations are complex and have to match spatiotemporal diverse requests to high-capacity vehicles while satisfying the driver, vehicle, and ride time constraints. Further, the system must plan for new requests that can come in the same day. Our idea is to combine the on-demand transportation with paratransit operations in the city, relying on the available slack in the system to ensure that we have more vehicles that can then serve a larger demand. In order to make the system more efficient, we developed an algorithm that focused first on the booking operations. It works by presenting new potential options for riders when they request a ride, ensuring that the new options better optimize the system. However, the riders have the ability to ignore all the suggestions and request the time that they initially wanted. The algorithm was presented at HCI conference this year and combines a reinforcement learning algorithm with a simulated annealing algorithm that has been tailored to paratransit operations. Once the bookings have been confirmed for the next day, the advanced planning algorithms work on generating manifests. Note that the problem itself is computationally very hard, and therefore in general current state of the art uses heuristics and only solves the problem for fixed batches at a time. Our approach is to use a rolling horizon to look at the future requests, which we already know as it is based on the bookings that we took, while solving the current batch. This approach generates more efficient results in less computation time. Finally, we solve the day of challenge. This is again a hard problem. The vehicles can break down, the requests can be cancelled, the drivers can become unavailable, and new requests can arrive. All the while, the traffic conditions in the city can change and roads can be closed. We approach this as an online planning algorithm where we formulate a semi-Markov decision problem, which is then combined with two heuristics which explores the best vehicle to insert the request and explores if a future request from a current vehicle can be swapped with another vehicle. This is done looking into the future using predictive models combined with Monte Carlo tree search in real time. On average, we can provide decisions within 30 seconds from the time of a new request assignment. These algorithms are being integrated into an online tool, which we are working to release to the agency soon as part of the pilot operations. Our primary focus on evaluation is to ensure equity, and we want to make sure that the design operation focuses on the people who need the transit most. Our current algorithms are exploring changing the operations and design of the fixed line as well, and then integrating it in the future with the microtransit operation. The second part of the evaluation method is to understand the equilibrium of the population's need, preference, and mode availability. A side effect of this analysis is that it provides a what-if tool to the city planners, and they can study the impact of changing preferences on the current transportation design. Combined with the new design algorithms and the potential redesign of the fixed lines, the two systems together provide an exhaustive methodology of updating and improving transportation option in the city. CARTA has begun to engage a commercial on-demand transportation company in a small zone to experiment with how well the community utilizes the on-demand transportation and learn from it as we integrate it and operate in a much larger area. The service currently has been limited to the blue zone, and it has been fairly well received, and a number of people have started using it. CARTA has also been active in the community outreach, working with the researchers to understand the community needs. The broader outreach of work is shown by international collaborations, which we are just starting. The first is Varanasi, India, and the second is in collaboration with Google in Nigeria. Together, we are very excited by the opportunities provided by the National Science Foundation, and we are now working to launch the on-demand algorithms developed by the team in a larger service area and then eventually integrate it with the fixed route services. Thank you very much.